The rest of Chapter 15 covers some interesting topics, functions and triggers. We are now in week 9, and this is where we stand in relation to our course outcomes. At the end of this module, you should be able to write both scalar-valued and table-valued functions. You should also be able to write database triggers. We want to understand the different types of functions and triggers, as well as some of their options. There are 4 types of T-SQL procedural programs. We've already covered the first 2. Remember that scripts are useful for those users with access to the SQL Server client tools, such as SSMS. Typically, these tools are used by SQL programmers and DBAs, not by application programmers or end users. Stored procedures give the SQL programmer control over who accesses the database and how. It gives you tight control over the security of the data. Since some application programmers do not have the expertise to write certain types of complex SQL queries, stored procedures can simplify their use of the database. User-defined functions are most often used by SQL programmers within the stored procedures and triggers that they write. Triggers are special procedures that execute when an action query, such as insert, update, or delete, is executed. To recap, stored procedures are used by SQL programmers to control who accesses the database and how, and by application programmers to simplify their use of the database. User-defined functions are used most often by SQL programmers within the stored procedures and triggers they write, and can also be used by application programmers and end users. Triggers are used by SQL programmers to prevent database errors when an action query is executed, and by SQL programmers to provide for updatable views. In addition to SQL Server functions, which you have already learned about, you can create your own functions. A user-defined function is also called a UDF, or just a function. You use code that is similar to the code you use to create a stored procedure. There are 3 types of user-defined functions. Scalar-valued functions return a single value. Table-valued functions return a table. And we're not going to cover multi-statement table-valued functions. Here's the syntax for creating a user-defined function, or UDF. The create function clause names the function and declares the input parameters. The syntax you use to declare parameters for a function is similar to the syntax you use to declare parameters for stored procedures. However, for a function, the declarations must be enclosed in parentheses. In addition, because a function cannot have output parameters, the output keyword is not allowed. Also, you have to pass parameters by position. You cannot pass them by name like you can in stored procedures. Furthermore, you cannot simply omit optional parameters like you can with a stored procedure. Instead, you must use the default keyword as a placeholder for the optional parameter. The returns clause specifies the data type of the value that is returned by the function. You code the statements for the function with a begin-end block. Within that block, the return statement specifies the value that is passed back to the invoking program. Since this statement causes the function to terminate, it is usually coded at the end of the function. It must return a value compatible with what you specified in the returns clause. And to delete a UDF from the database, use the drop function statement. When you delete a function, any security permissions that you are assigned or that you assign to the function and any dependencies between the function and the tables and views it uses are also deleted. Like a stored procedure, a UDF can accept one or more input parameters. The function shown in this example accepts a parameter named vendor or @vendor_name. However, a UDF cannot be defined with output parameters. Instead, the return statement must be used to pass a value back to the calling program. To invoke a table-valued function, you refer to it anywhere you would normally code a table or view name. You should prefix the name of the UDF with the letters FN. Unlike other database objects, you must specify the name of the schema when invoking a UDF. The schema in this example is DBO. So in this example, an integer that contains a vendor ID value selected from the vendors table is returned. To call or invoke a scalar-valued function, you include it in an expression. A statement that invokes the scalar-valued function is shown here. Here is another example. Here we create a function called fnBalanceDo with no input parameters. We will return a value with the data type of money. We enclose our SQL code and return statement between begin and end statements. Unlike in a stored procedure, the return data type does not have to be an integer. This function will sum up the balance due for all the invoices that have a balance due. Balance due is calculated by taking how much money is owed, invoice total, then subtracting how much has been paid, payment total, then subtracting how much has been put on credit, credit total. If you find yourself repeatedly coding the same expression, you may want to create a scalar-valued function for the expression. This can save you time and make your code easier to maintain. You create a simple table-valued function by coding the table data type in the returns clause of the create function statement. This example creates a UDF called function top vendor due that returns a table that contains the vendor name and total balance due for each vendor with a balance due. It has one input parameter at cutoff, which is optional because we assign it a value of 0. This parameter is used in the having clause to return only those vendors with total invoices that are greater than or equal to the specified amount. In this example, we set the input parameter to 5,000, so the UDF only returns a table with vendors having invoices totaling over 5,000. They need to pay up. You can also use the table returned from the UDF in joins.